This question looks at some probability distributions and a manipulation of probability distributions. This one's a discrete distribution. Suppose that a green light in an intersection is on for 25 seconds at a time, yellow is 10 seconds, and it's red for 65 seconds. If he can arrive at any time during this light cycle, we want to try and figure out the probability of arriving exactly at a green light. Right, so A, we're asked for the probability distribution of success, when success is arriving at a green light, in one trip. So we drive to the shops or whatever, and we drive through the light, and what's the probability that light at the intersection is green? So this one's fairly straightforward. It's favorable outcomes over total outcomes, right? So favorable. Well, that's going to be the light's green for 25 seconds. And the total possible outcomes, the sample space, if it were, that's the green light plus the yellow light plus the red light, which is 65 seconds. So we've got this 25 seconds divided by 100 seconds. So it's 25% chance that we arrive at a green light. That's the probability, but we're asked for the probability distribution. If you got a single success or failure, it's called a Bernoulli distribution. So let's say our success, let's just call this a random variable x. So the distribute x, this twiddle in probability is read as is distributed as Bernoulli. Bernoulli P. Bernoulli has one parameter, the probability of success, and it's 0.25 in this case. The next thing we're asked about is extending the Bernoulli trials to 25 times. So obviously, if you've got success and failure, which is a Bernoulli trial, a repeated Bernoulli trial has a binomial distribution. So a binomial distribution has two parameters, the number of times and the probability of success. So for B, the probability of success in 25 trips, so we'll just redefine our notation as X is the number of successes in N trips distributed binomial. It's NP, so we got 25 and we got 0.25 as our distribution. Now think, yeah, so we also have a formula for the probability of X, little x successes. So that's a particular number. So N choose X times the probability P to the power of X, probability of success, times the failures. Right, so this is really the probability of success times the probability of failures times the number of ways you can organize them. We can explicitly write this down because we know N and P. So That's 25. I use the brackets rather than the choose notation. You can write out what that is in factorials if you want. Okay, you can also compute the expectation of this. That's just n times p, which in this case is a quarter of 25, which is 6.25. You can work out the variance as well. That's just n times p times 1 minus p. That turns out to be 6875. And you can put units on this. This is successes, and this is successes squared if you want to put units on it. The last part of the question asks us for the probability of more than 9 successes and at most 12 successes in 25 trips. So we're going to apply our ideas of using this binomial distribution. So to put some notation on what we're actually being asked for, x is explicitly greater than 9, right? So more than 9, at most 12, so that at most is less than or equals to 12. So because we've got a discrete distribution, and it's not, we've got 10, 11, and 12, right? This isn't actually particularly difficult to break this down. Plus p x equals 11 plus p x equals 12, like so. And because we have our formula up here, we've just got to stick in for 10, 11, and 12. So this is now a calculator exercise. So I'll just write out what we're actually sticking into our calculator. 25, choose 10, 0.25 to the power of 10, 0.75 to the power of 15, plus 25, choose 11, 25 to the power of 11, 0.75 to the power of 14, and 25, choose 12, 25, 12, 75, 13. So this is some icky number. When you actually compute it, it is allegedly 0.68. Okay, so it's a pretty slim chance. It's about 7% of the time you're going to rock up to the lights and find it's green. 7% of the time, sorry, you'll have between 9 and 12 successes on your 25 trips. So yeah, so every 25 trips you can expect about 7% of that set of 25 trips you'll encounter between 9 and 12 green lights.